Calbeckistan, where anybody can learn math. I'm Mr. Calbeck, and this is a bonus episode in our factoring crash course, where we're going to be looking at some challenging test questions that your teachers might throw at you. Maybe extra credit, or if you're in an honors class, this is going to be your kind of question. So this is a problem here. If we look at this one from the beginning, it is possible to factor with the same method that I taught you before, where we multiply the first and last terms together, but you're going to end up with some more challenging numbers with that, and some of them won't come out as whole numbers, and your teachers will get mad at you for that. Factoring should always have whole numbers inside the parentheses, or you're probably doing it wrong. So we need to find another method for this kind of question. And if you ever see a fraction in front of your x squared, that should be very suspicious to you. Because remember, my rule is always look for a common multiple. Now, your teachers are going to be expecting you to get stuck on this and get confused, so they throw it in as an extra credit question. But if you remember to look for a common multiple, you can actually factor out in a 1/2. Now, that's kind of a weird idea to factor out a fraction, but if we think about what we're doing when we factor out a common multiple, that's going to help you with this. So let's see what would happen if I divided out 1/2 and 1/2. You have to think about how fractions work for a minute, but anytime you divide something by itself, you get 1. So if I were to factor out a 1/2, I'm going to be left with an x squared here. The 1/2 would be out front, and x squared is really easy to factor. So let's see what happens if I divide by 1/2 all these other terms. If that makes it simpler, then I can just put the 1/2 in front here, and I've got it. So if I divide -5 by 1/2, I need to think about what's happening when I divide by a number less than 1. If you divide by a number less than 1, you're actually making the number bigger. When you divide by 1/2, it's the same as multiplying by 2. Real quickly, the reason for that is when you divide fractions, so -5 over 1 divided by 1/2, to divide fractions, you have to multiply by the reciprocal. What that means is you change the division sign to a multiplication sign, and you have to multiply by the reciprocals. Reciprocal just means the flipped fraction. My students love to use the phrase copy dot flop when you're dividing fractions. You copy the first term, you change the division sign to a dot, and you flop the second fraction. So copy dot flop. And so -5 times 2 is -10. And that's what we get when we factor out a 1/2 from -5. When you divide by a fraction, you actually end up multiplying by something. So we're going to have a -10x here. And -12, so we're going to do the same thing. Dividing by 1/2 is the same as multiplying by 2. So that's going to give us a -24. Now, this looks way easier to factor. We can go back to the very first episode on factoring to do this one. We're looking for multiples of 24, or -24, that add to be -10. We can make a quick chart over here, and we can solve this. One and 24 won't work. 2 and 12. If I make the 12 negative, that one works. So we're done. We've got x minus 12 and x plus 2 with a 1/2 out in front. And this has been factored. So when you have a difficult test question with a fraction somewhere in your problem, see if you can factor that fraction out and factor what's left. You'll find the problem gets much easier if you do that. It's going to make your life a lot better. All right. Let's try another one that's going to be even more challenging looking to you guys. All right. I hope you're not shaking in your boots too much with this one, but there's another variable in this problem. Not just an x, but we also have a y, which makes things look a lot scarier. The cool thing about this is you can still use this same factoring method because x squared is in it as the biggest x term and y squared is in it. If you see something that looks like this, try to factor it with the same method. You might be surprised to see that you can still do it. If you want to try it on your own right now, go ahead and hit pause. See if you can use the same method that we've done before on your own, and then you can hit play and see if you got it right. For those still watching, I'm assuming that you'd like to check your work. So let's go ahead and start this, and we're going to multiply the first and last terms together. So that's actually going to multiply to be 6, and it adds to be 5. But there's a problem here. You got to be really careful with this one. All right? You can hopefully see that this is 2 and 3. But in our previous problems, when we have rewritten the middle term, we've always had it be one variable. The temptation on this problem is going to be to rewrite this middle term as 2x plus 3y. This is wrong. Please don't write this. Okay? I see a lot of students try to factor it this way, but it won't work, and here's why. This is not a sum, or these don't make up a sum of this one, because you can't combine x and y. So in order for you to combine these two terms, you have to have x and y in both of them already. So instead of it being 2x plus 3y, or 2y plus 3x, either way, it doesn't work. You have to have 2xy plus 3xy. Now the terms are the same, and you can combine them. And you can factor the rest of it. Let's put parentheses around this one, put parentheses around this one, and we're going to go ahead and see if we can factor out the greatest common multiple. X squared plus 2xy, the greatest multiple there is going to be x. There's an x in this one and an x in this one. So if we factor out an x, that leaves me with x here. If I divide the x out in this second term, all that happens is the x part of it goes away. So I'm left with 2y. Over here, the greatest common multiple is going to be 3. And they both have a y in the term, so we can divide out a y as well. So we can divide out 3y. So if I divide that one out, it gives me plus 3y. This one is just left with an x. And over here, 6 divided by 3 is 2. Y squared divided by y is just y. Remember, whenever you're factoring, these two parentheses need to be the same, and they are, so we got it. We can factor out the entire parentheses, which gives you x plus 2y and x plus 3y. And you factored it. Again, as always, if you're nervous about a problem like this, multiply it back together with FOIL or double distribution. And make sure that you got this one right. It is a little bit scarier to see an extra variable in here. But a lot of teachers will love to throw something in there with an a and a b or an x and a y, just to see if you can extend your thinking. Again, the big error that I see my students make on this, though, is forgetting to make this middle term a combination of both variables. If you remember to do that, that means it will combine to be this middle term, and you can factor it normally. All right, if you have any other additional questions or any other weird factoring questions, please let me know in the comments. Next time on the Factoring Crash Course series, we're going to talk about why we factor. How do I use this? Why do my teachers want me to factor all the bloody time? Sorry for all you UK people, I didn't mean to curse there. Probably should censor that. What do you think?